Hi, everyone. I think we're just waiting on one more, so let's give them another minute to show. All right, well, let's just go ahead and start talking, and we'll see. So first, I did post a lecture. Hopefully you were able to see that up there. However, I did not, unfortunately, post your exam grades yet. I apologize. Give me one more day. I'll get them posted. And then we can talk about them as much as you want. But we'll make everything work, given that delay in posting them. But so I will, it is like my top priority at this point. So I will get it done for you. So with the turnaround of this, now that you've already had the lecture on repeated measures, but we haven't done any practice really for the in-class practice for the ANOVA or Kruskal-Wallis. The question is, maybe you've had enough of that with the homework. Maybe you still want to see me go through one. Maybe you want to try one in class. I'm not sure. And then for the repeated measures, we probably should attempt one, either with me doing it and you guys watching, or you guys actually trying one in class. So I've created some data sets. I have all the options available. Let's start with ANOVA. Are you guys wanting to either see or do one, or are you feeling done with ANOVA and Kruskal-Wallis? So if you can raise your hand, or you know what I mean, raise your virtual hand, if you would like to see or do one.
I just have one question about the
Of course.
ANOVA.
Yeah.
So I think it's the ANOVA at the end in the slides. It says when you want to do a case analysis to look at the means and see if there's significant differences between the means for the groups. And I think you have the option of like select cases and you can run something. But my SPSS just computes it itself. Is that right?
So I'm missing exactly what you're referencing, because with the procedure, you generally are running everything. Oh, no, because you're with the ANOVA, you're running the post hoc, like a priori. You're selecting post hoc.
Right. So it comes out by itself, right?
Yes.
In this, okay. For some reason, the way I read the slide was that you had to go back in and rerun something so that you could see the differences.
Oh,
groups.
no, it should be there. It should be there.
Cool.
And it should be the Tukey and the games how that's there. And I did just want to point out that it's like more branches of the tree breaking off this time, and it's even a little bit, well, I guess I wouldn't say it's more so with the repeated measures ANOVA, but it is somewhat the repeated measures ANOVA too. But with the ANOVA, if you recall, the trick there is, did you meet the homogeneity of variances? And if you do, you can look at the standard ANOVA output and the Tukey. If you didn't, then you've got to look at the robust equality of means output and the games how. So I just wanted to point that out. So, okay, so there was that one question. So I didn't see any hands go up, so I am guessing we're feeling done with ANOVA for now.
I actually kind of want to, and I can like stay, like if we finish earlier, I can go into your office hours because I don't want to keep anyone else like behind. But I kind of was interested in seeing an example for an ANOVA Welch's test.
An ANOVA Welch's test.
Yeah.
Yes, I can definitely do that.
I don't know how anyone else feels or if they feel like they want to look into that because I know that can take time, but.
No, that's fine. We can definitely do it. I may have to fudge the data a little bit, but we can do it. If you're willing to pretend with me a little bit that things might look slightly different than they do, we can definitely work through that. So that's no problem. So any other hands for that? Otherwise, maybe we'll push that toward the latter part. Okay, so we'll just, if that sounds good, let's go through some other stuff first, and then we probably will end early, and we can, you and I can definitely go through that. So I do think for repeated measures, we should probably do at least some sort of activity around that. I am going to leave it in your court. That's my opinion, because I think before you tackle the homework, that might be helpful. So someone must have lost their connection. I don't know what's going on today. Okay, I think we're all right. All right. So okay. So why don't we leave it at like this? If you were given choice, would you rather see me go through a repeated measures ANOVA and Friedman test, or would you rather practice one? So raise your hand if you'd rather practice one, I guess.
Would it be possible for us to go through it on our computer while you're demonstrating it on your computer, like sharing your screen?
Absolutely, that's a good idea. We could try that. Do we like that idea?
My computer might crash if I have SPSS open while I have Zoom, so I'll just observe you.
Okay, yeah, that's certainly fine. Yeah, that's a good point. Yeah, okay, so let's do that. I'll open up what I created, and I'll try my best to walk through step by step without cheating and looking at Laird, but I don't promise I won't. But I'll walk through it step by step, and you guys can follow along. So the data I want to work with first is in, and I'll give you a chance to get to this point, is in D2L under content, under repeated measures under data, and then there's two files for repeated measures ANOVA and Friedman, and it's the first file, file 1. And then I have to open up the data on my side. So I will, and then I'll share. Okay. I remember this one. Okay, so this, go back here and share this. Okay. All right. So I'm going to share my data, and then once I run it, I'll share the output with you. So if you want the background story to this data set, any town city council has voted to replace the old style light bulbs and residential street lighting in all 26 districts with new energy efficient lights that last longer, require less power, and are substantially brighter. Any town has a fairly steady crime rate from month to month in each district. Research question. The Anytown Police Department wanted to determine if this change in lighting influences residential crime rates. Okay. So, great. We're looking for some change in crime rates. And as you can see, the data has 3 months here, March, April, May. So we'll be looking for some change. Now, I do want to point out for our purposes for this class, even had it said a decrease, we would still treat this as two-tailed. The reason is that they'd have to specifically identify all their custom contrasts, and then we would have to run it specifically in that way, and we're not going to do that. It's a little bit, I think, much for the class, for the purposes of what we're trying to get through and understand. So we're just going to treat it always as two-tailed for the ANOVA, regular ANOVA, repeated measures ANOVA, and the associated Kruskal-Wallis and Friedman procedures. Okay. We'll go back again to one-tailed and two-tailed tests when we get back into some other statistics in a little bit. But for now, let's go ahead and do that. Okay. So the first thing I want to do is go to my Explore procedure. So I'm going to go under Analyze, Descriptive Statistics, and Explore. Now, the fact that district is here is kind of interesting because I could see it throwing someone off. Just think of it as an ID number. You know, it's nothing. It's nothing to be concerned about. It's just a space holder or ID number. Okay. So I'm going to bring March, April, and May over to my dependent list. Okay. And then statistics is fine, but I am going to go under plots, get rid of the stem and leaf, and put in the normality plot with tests. And hopefully this part is starting to get a little more familiar as you've been doing it for a few different tests. And we hit continue. And then we hit OK. And now I think you're probably still seeing my data. So I'm going to switch over to my output so you can see my output. Okay, so here we go. We've got some nice means and standard deviations and standard errors and all that good stuff here. I have medians if I need that later. All good. And then I look at my tests of normality, my Shapiro-Wilk in particular, and I pass all three. I passed for March, I passed for April, I passed for May. Bear in mind, that's what I had to do. Even if I failed for just 1 month, I would be over to Friedman land, okay? I wouldn't be running the repeated measures ANOVA. So I've got to pass all those normality tests. Next, I've got to pass my box plot test in addition. So here is, oops, I skipped over March. Here's March, that looks pretty. Here's April, very nice. And here is May. No outliers. Perfect, I passed everything so far. So that's great. Okay, so now I can actually run the one-way ANOVA. So that's what I'm going to do next. I'm just going to pick up the analyze right from here rather than go back to my data because there's no reason to. And this way I won't have to switch back and forth screens. Okay, so I'm going under analyze. Oh, I almost forgot myself for a second. Okay, analyze general linear model, repeated measures. Okay. So instead of calling this factor 1, I think I'm going to go ahead and call it month. And there'll be 3 levels for month. So I add that. What's my measure name? I'm going to call it crime. I think that works. These really don't matter what you call it. I mean, it's just a name. Just make it something simple and easy, and preferably, you know, nothing that's going to confuse anything later on. Just a nice lowercase short name. And then I hit define. Okay. And then if you recall, the next step is going to be to bring March over to crime 1, or 1 crime, April over to 2 crime, May over to 3 crime. Okay. So far so good. Now, what's the next things I'm going to have to do? Oh, I may not remember all of them. Okay. So under model, I don't need anything. So we hit continue. Under contrast, I don't need anything. Also hit continue. Under plots, this one we want to do. Under plots, we bring month over to horizontal. We add it down, and we leave it as a line chart. And if you felt like being fancy, there's nothing wrong with adding error bars. Layer doesn't say to do it, so I'm not going to do it here, but you could. So I hit continue here. Next, I'm going to click on EM means. We're going to display means for the month. So I bring month over. Compare main effects, we check off, and we're going to choose Bonferroni. And if you remember, you could also choose the, I'm trying to remember how you pronounce it, I think Shidak. You could choose that other one, that third one in the list. That would be fine too. But again, we'll just stick with Bonferroni for convenience sake. That's a pretty good one. And we hit continue. And then, so that takes actually care of our post hoc. Like that's going to compare all of our post hoc stuff. So we're good. And then under options, we click off descriptive statistics and estimators of effect size, or estimates of effect size. And that's all we need here. Continue. And I think we're ready to go. So in a moment, I'll hit OK and see where we land. If anyone wants me to pause, go back, let me know. Okay, so I'm going to hit OK. And we get all of this stuff. So let's look through it. First thing, I notice we get some nice descriptive statistics that give us means and standard deviations, and of course our N of 26. That's what we had. Should definitely be the same for all 3 months. Okay, the next thing we're going to do is check Mauchly's test of sphericity. That's this sig value right here, the 0.231. Okay. In our case, it's not significant, which means we get to use sphericity assumed. Had this been, let's just pretend for just a moment that this had been 0.008, we might want to just make note of this number here because we're going to report it later, the greenhouse geyser number, the epsilon for it. Okay. Then, because we do have sphericity assumed, we get to use the first line, the first row by month, and the first row by error. Both say sphericity assumed. Had we not gotten the sphericity assumption, we would be using the greenhouse geyser numbers for both month and for error. Okay. And you can see the F is actually identical for all of those. What really changes here is the DF. Oh, we have a question coming in. Yeah. What are the error numbers for? let me walk you through how you'd actually report this, and maybe that'll make it clearer. This is just like when we had the, with the simple one-way ANOVA, if you had the between and the within. This is like your between, month is like your between, errors like your within. So if you're reporting this, it would be, with sphericity assumed, it would be F2, comma, 50 in parentheses. So F parentheses 2 comma 50 close parentheses equals 60.006 comma P less than 0.001 eta squared of partial eta squared, excuse me, of 0.706. Okay, good. If we were reporting the greenhouse geyser, because we didn't have sphericity, it would be F parentheses open 1.794 comma 44.848 close parentheses equals 60.006 comma t less than 0.001. And then again, partial eta squared equals 0.706. Okay, so it's not too surprising to me that these are very close, but do make sure you're reporting the correct one here. Okay, so that's how we report our F. Okay, so clearly we have a significant F. It was, the sig value was clearly less than, we'll assume an alpha of 0.05. It was clearly less than that. So we're in good shape. So now the next thing we really want to do is look at our pairwise comparisons down here. Okay. So we're going to look at pairwise comparisons. Now this is very much the same as what we did for the one-way ANOVA. In other words, we're going to compare 1 to 2, 1 to 3, and 2 to 3. Or if you prefer, you can do the opposite. You can compare 2 to 1, 3 to 1, 3 to 2. The whole point is, if I'm comparing 1 to 2, there's no reason to compare 2 to 1. They're the same. They're always going to have the same sig value. They're always going to have the same standard error. They'll even have the same mean difference with the signs reversed. And even the lower and upper bound are, as you can see, exchangeable with the signs just changed. Okay, so 1 to 2, month 1 to 2, in other words, March to April. What's my sig value? P less than 0.001. Okay, important difference there. 1 to 3, what's the p value? P less than 0.001. 2 to 3, get out of there. 2 to 3, what's the p value? 0.347. That one's not significant. What the difference between 1 and 2 and 1 and 3 is. And the easiest way to know which direction it's in, if I want to note that, I mean, there's a couple of ways, but I'll just show you. Here are means right here that you can use, or you could use the initial, even better. I think much better actually. Let's go ahead and use these descriptive statistics means. Okay. Yeah. And then finally, you see that we have this nice little plot here that shows, you can see the difference between 1 and 2 and 1 and 3 looks a lot bigger than this distance between 2 and 3. So the results make sense. Okay. That's the one-way ANOVA. And you can see sphericity was able to be assumed, but we did talk through if it wasn't able to be assumed. Any questions you want to ask about that? Okay, well, feel free if you want to afterwards. I'm going to now open up the next data set, which is sitting right here. And I don't remember the story on this. If you like the stories, I have to find it for you. Here it is. The staff at a mental health clinic wants to determine if their current form of short-term therapy substantially reduces depression. Prior to their first treatment, each patient will be asked to complete the Acme Depression Inventory, which renders a score from 0 to 75. 0 low depression, 75 high depression. Patients will be asked to complete the same instrument at the conclusion of their appointment on week 5 and at the end of their final appointment on week 10. Okay. Okay, so we're looking at baseline, week 5, and week 10. Okay, so let's start the process in the same way. Analyze, descriptive, and explore. And this time, once again, I can ignore the ID, just bring over baseline, week 5, and week 10 to the dependent list. And under plots, uncheck stem and leaf, check normality, hit continue, and hit OK. And we can, once again, we have some nice means, medians, right, mean and standard error, and median and variance and standard deviation. So we have all that good stuff for both, for baseline, week 5 and week 10. Well, it looks like we have a problem this time. Baseline has a significant Shapiro-Wilk. That 0.008 is absolutely greater than 0.05. Let's try that one more time. Sorry, 0.008 is less than 0.05. It's significant. We have a problem. We are not hitting normality for the baseline group. So we already know we're going to do a Friedman, but just for fun, let's look at the graphs. Baseline actually looks okay. Ooh, some problems with the 5 weeks. And a little problem with the week 10. Okay, so we're going to run Friedman this time. Okay, so let's go ahead and get into that. Okay, so I'm going to analyze. Non-parametric, here it is, non-parametric tests, related samples. I'm going to go to my fields, bring over baseline, week 5 and week 10. Then under setting, I mean, I could just run it right now. I think I will. I think I'm not going to choose my test this time or change anything else. I think I'm just going to leave it as it is and run it just like that. So much less setup than the ANOVA. Okay, got nervous for a second. Okay, so first thing I see is my sig value of 0.140. Looks like I'm going to retain the null hypothesis or not reject the null hypothesis. And then I'm given this information about my test statistic, my degrees of freedom, and here's that p-value again. Here's how this looks. Oh, I think I just figured out the question from before. So, no, this question, okay. I realized the question might be more appropriate for the Friedman, maybe, where, yeah, let's see a question here. Yeah. Yeah, you're right. Okay, so if it was significant, you do have to click on something to bring up the pairwise comparisons, if memory serves. This may be where I have to cheat a little bit, because I'm not remembering exactly where you do that. Not here. I might switch you over to layered real quick just to look at that one piece together, because I want to make sure you have that as to where you would go to actually run those pairwise comparisons. So let me do that. Right. So for the Kruskal-Wallis, I believe that the pairwise comes up automatically, but I'm not convinced it does for the Friedman. But let's just take a look. Let me just switch over real quick, and let me take a look. So I'm gonna switch to here, and then hopefully I don't have to log in again. Here's the Friedman. Yeah, we should also talk about generating median statistics. Okay. Okay, so here, I'll switch you in just a sec. New share to layered. Okay, so yes, one other thing I should have done is go under compare mean. So I didn't do this because it's under the descriptives. It's under explore, your medians. I keep pointing out how your medians are there. If you don't like that, then you can run this compare means and just put in that you want to report medians, and all it's going to do is report medians for you. Okay, so I'm just pointing that out, but you can just use explore. Okay, so now, oh, okay. I think I saw two things come through, so hang on 1 second. Okay, no, I guess there's just one chat. Okay, no problem. Okay, so now let's take a look at this interpretation. Actually, 9. So here's pretty much what you get. Yeah, you're right. This does look a little bit different. I am running 26. This must be 25 as to how you get the automatic one to come up. Because what they're saying is essentially there should be a little box here that you switch. I'm going to guess it automatically comes up, but I can fudge the data real quick and run it again to see if that happens. So hang on, let me switch you back to the output, because I don't see a space where that's going to, yeah, there's no space for that to come up. So yeah, that's a good point. Okay, so is this number 2? Okay, I know what we're gonna do. I'm gonna do a bad thing, and I'm gonna run because I know what's significant. I'm gonna go ahead and run the other data set, data 1, as a Friedman, just so we can see what happens, okay? Just so I don't leave you hanging on that point. So I have you on my output, that's fine. I'll go back to my output. Okay, so what I'm going to do now that I have the other data set highlighted is I'm going to go under Analyze, do the same thing again. Non-parametric tests, related samples, fields, March, April, May, and 1. Why did you not show me the output? You probably can see it, but I can't. Okay. I gotta switch. Okay, so here it is. Here's the output. This time we have significance. Yes, it ran it automatically. So there you go. If you have significance, and I believe this is true for Kruskal-Wallis and for Friedman, at least on version 26, it's going to run it automatically. I'm just wondering, is anyone running on version 24 and having a different experience that they want to share or talk about? I'm just going to look at this a little bigger. Give me one sec. Okay, maybe not. So yeah, is anyone actually, so do I have everyone here? 1, 2, 3, 4, 5, 6. Yeah, so is anyone here actually running the cloud version, the free version of SPSS? Can you raise your hand?
I was.
You were. Oh, but you're having problems. So I remember you saying you thought this whole thing was going to explode on you.
Yeah, so sorry, I was able to run the first data set, but I wasn't able to do the second one for some reason.
Yeah, that's fine. I was just curious if your experience was different, if you had run it, if you need to do that extra step of the pairwise, and we can talk about it later if you want to like share a screen with me and show me. It looks like almost everyone else is running 26, so you're going to be in the same boat I am, and it's going to do it automatically for you. So Brian, if you want to check that out later, just let me know.
Okay.
Okay, so you've seen a Friedman, you've seen an ANOVA. Any questions about anything you want to ask right now? If not, I'm going to opt for just a maybe, because we haven't, I don't think we need too much more. Maybe just a 5-minute break, and then we'll get into the presentations for today. We have 2, if you recall. So anything you want to ask me before we do that?
I don't have a question, but I thought that this was really helpful, like getting to hear you lecture about it first and then watching you do it. I think is going to be a lot, like help me for the homework a lot more. So thank you.
Oh, okay, good. I see another, looks like positive reactions. Okay.
I 100% agree. It was nice
Okay.
to like be able to pause the recording when you needed to, so I could write down more, and then
Okay.
like refer back to it and practice.
Okay, good. I'm glad it's working. I actually appreciate the feedback. So good, we'll continue. Okay. Yeah, sorry, something else?
Yeah, I have probably a stupid question. Is a one-way ANOVA different than the ANOVA Welch that we were talking about before?
Oh, the Welch is just, remember the robust test for equality of
Right.
means? That's the Welch.
Okay, that's what I thought. All right, thanks.
Yeah, of course. So that's just what you run if you don't meet homogeneity of variance. And it's run already. I shouldn't say you run. It's what you look at if you don't meet homogeneity of variance. Okay. Anything else? All right, 5 minutes, and then we'll return and ask any other questions at that time, and we'll do the 2 presentations. Okay? All right, I'll see you in 5.